Hello and welcome you all. Today I am going to discuss with you about modulus of elasticity, creep and shrinkage, and we will solve some problems related to this. As we know, modulus of elasticity is equal to stress divided by strain, or it is the slope between stress and strain. But concrete is not a homogeneous material, so it has different strain value at different time period. The strain in concrete is of two types, that is short-term strain due to instantaneous loading and long-term strain due to creep and shrinkage. So let's talk about creep and shrinkage. Creep, it is nothing but a long-term strain. It is the property of concrete due to which inelastic or permanent deformation occur. So what is inelastic deformation? It is a change in the shape of concrete which cannot regain by the age of concrete. As you know, total strain is equal to elastic strain plus inelastic strain, and we know elastic strain does not depend upon time, but inelastic strain depends upon time. So time dependent total strain is equal to creep strain. Note this, make this point as a note. Time dependent total strain is equal to creep strain. This is a previous year IES question. Coming towards shrinkage of concrete, it is a volume reduction due to loss of moisture. As we know, water present in pores of material, due to long time it evaporates, due to which volume of concrete reduces, which is called shrinkage of concrete. Due to shrinkage, cracks will form, and we know excessive cracks causes loss of serviceability in concrete. Note this point. Due to shrinkage, cracks will form in the surface of concrete. It is again of two types, that is drying shrinkage and chemical shrinkage. Drying shrinkage is due to loss of capillary water, and chemical shrinkage is due to hydration of cement. Then coming towards modulus of elasticity, which is divided into two types, that is short-term modulus and long-term modulus. It is again divided into short-term modulus is again divided into three types, that is initial tangent modulus, and secant modulus. Let's talk about these three. Initial tangent modulus. If we draw a tangent from initial point, the slope is called initial tangent modulus. From the graph you can see this is the initial tangent modulus. This is the initial point, the tangent is drawn, this is the tangent is drawn, it's called initial tangent modulus. Second, tangent modulus. If we take any stress point and draw a tangent by taking that point, and we draw a slope at that point, from the slope we get, it's called tangent modulus. See, if this is the assuming stress point, this is the assuming stress point, and this is the tangent drawn at this assuming strain point. If we draw, after drawing a tangent, the slope is called the tangent modulus. Then coming to the secant modulus, which is if the tangent between the assuming stress point, this is the assuming stress point, and this is the initial point. If we draw a tangent between initial tangent point and assuming stress point, the slope we call the secant modulus. Note the slope, this is the slope, is called the secant modulus. And for every type practical purposes, we use secant modulus as our base modulus of elasticity, or secant modulus is equal to short-term modulus. See, this is the definition of initial tangent modulus, and secant modulus. But as per IAS 456-2000, short-term modulus is equal to 5000 root FCK. This is an empirical formula given by IAS 456-2000. Unit is in Newton per mm square. But make a note, this equation is based on initial tangent modulus. This equation is based on initial tangent modulus. This equation is not by secant modulus. This equation is based on initial tangent modulus. This is a question This is in previous year IAS question. Coming to the long-term modulus, it is also called effective modulus or dynamic modulus of elasticity. Note, this is also called effective modulus or dynamic modulus, which is given by IAS 456, that is 5000 root FCK divided by 1 plus theta. Then what is this theta? Theta is called creep coefficient. It depends upon the age of concrete. As you can see here the age of concrete and creep coefficient value are given. For 7 days it is 2.2, for 28 days it is 1.6, for 1 year it is 1.1. Then another question come here. If any another value of age of concrete is given, just example 300 days, just example 25 days, 10 days. So what you can do that time? You can simply interpolate the value, but by taking age of concrete in log scale. Note this, age of concrete is in log scale. As I have taken 25 days, I have taken log 28 minus, I have interpolated this. This is the interpolation formula. You all know this. Log 28 minus log 7 divided by log 25 minus log 7. 1.6 minus 2.2 divided by x minus 2.2. What is this x? X equal to creep coefficient of 25 days concrete. Okay, creep coefficient of 25 days concrete. So what is creep? Again, another formula given by IAS, that creep coefficient equal to ultimate creep strain divided by elastic strain at that age. This is another formula given by IAS. You can find out by using this formula or this formula. Okay. So let us solve some questions. The modulus of elasticity of concrete mix of M25 grade as per IAS 456 2000. So what is the answer? This is a very simple question. FCK is 25 Newton per mm square. Put this is 5000 root FCK and which is equal to FCK is 25, so answer is 25,000 Newton per mm square. Unit is in Newton per mm square. Okay, let's solve next question. The modulus of elasticity E is equal to 5000 root FCK, which is short term modulus. Specified is in IAS 456 based on which modulus? This is I have given this that this is based on initial tangent modulus. Okay, not based on secant modulus, not based on chord modulus, not based on tangent modulus. So what is chord modulus? If we draw a tangent between any assuming two stress point, okay, not from initial point, any assuming two stress point, and after drawing a tangent, the slope is called the chord modulus. So our question is the modulus of elasticity based on which modulus? The E is equal to 5000 root FCK is based on which modulus? This is based on initial tangent modulus. Okay, let's solve next question. What is the 300-day effective modulus of elasticity of concrete for M25 grade? See here, it is given effective modulus. Effective means long-term modulus. So here creep coefficient value is not given, and the age of concrete is given 300 days. As we know, for 365 days it is 1.1, for 28 days it is 1.6. so for 300 days let's take it x, and by interpolation you can get the x value or creep coefficient at the rate 300 days equal to 1.1382, and after getting the creep coefficient value, we can easily put in the empirical formula given by IAS, that is 5000 root FCK divided by 1 plus theta, and you can find out the solution of this question. This is 11,692. So if it is for short term, then it is 25,000 as it is given effective modulus. So answer is 11,692 Newton per mm square. Thank you a lot.